Good day, everyone. This is Webster here. I'll be taking the building of AI models in industry perspective. Thank you, Computer Science Zimbabwe, for giving me this opportunity so that I can share what I've experienced and what I know very well that what happens in industry towards building AI models. So today the focus will be on one of the things that are very important in building AI models, which most universities not care to look upon. We're going to focus on things that the industry are so concerned about, which the academics are not so concerned about. And academics, the much concern is about the complexity of the architecture of AI model, the performance, but that is not what is very important to any industries. So there's an industry perspective regarding training of AI. What the industry focus on is particularly the data and the compute and saving and hosting of AI models. So in this talk, we're going to discuss about building AI models. We're going to look at data sources, extraction, cleaning, computing, saving, hosting. These are the things that are very important in industry. And so without wasting much of our time, we're going to, as I explained to you, that we are going to look at the sources of training data, the extraction methods, data cleaning pipeline, compute, CPU versus GPUs, AI saving and hosting. Yeah, so this is the first point that we're going to look at, which is the sources of training data. So where does the real world ML and LM data come from? Data is very important in training AI models. So in the industry, there are various sources of data. The first one is operational databases from databases like Oracle, MySQL, and Postgres. So in banks and in telecoms industries, the very source of information the very first source of data for training AI models is from their operational databases. So that is system from ERP, CRM, billing system. This provide a structured way of data. Then we also have spreadsheets and files, finance reports, CSV, Excel, JSON, and so on. For example, if you're looking in the context of law firms, this way you find a lot of files, files in PDF format and Word format. So these are sources of data that are available in industry to train LLM models. Then in other contexts, we have the open web, where you can scroll the data from the internet based on specific things specific criteria that you need. Download, you just scrape it from web pages and you gather that data. The other thing is consent and voice from interaction with the customers. You can get this transcript from the call or the call recording themselves. There's other way of getting source. There's another form of where data is comes from industry when we're training AI models, then API and streaming. There's another source for getting data, and synthetic and LLM-generated. That's another source of data. So one of the things that is important in industry is data. So we will see, as I will be explaining the next slide, that it's not about the quantity of data, but actually the quality of data. Various studies have been conducted by there's a paper published by Stanford where it indicated that the performance of AI model, where they're looking specifically for LMs, is greatly attributed by the quality of data rather than quantity of data, or even the complexity of the LLM model. So we're going to look at the data cleaning process. This is very important process about the extraction, the data extraction method. So we talked about the extraction of data, well, sources of data. I mean, then we're moving to data extraction methods. So we cannot talk about extraction method without us having where our data is going to sit. So in industry, the very thing that is very important is where your data is going to sit. So one thing that is very important is to have a separate like a data warehouse, data lake that you store your data that you're going to use for whether it is descriptive analysis or for machine learning training. So one of the things that are highly available is the Adobe ecosystem, which is an open source system, which is available. We have various vendors that provide enterprise grade way of this storage system. The Adobe ecosystem with Cloudera, and computer science in Zimbabwe is actually made its own, which is an African, made by Africans, which is a so-called data platform, which is HDFS, it is IceBake, it is Kafka, it is Hive, it is Chino, it is Presto. One of the things that's being used by in the industry, um, which has it have the stake that actually is being that is now relevant, that is being used in industry. So before we talk about um, uh, uh, extraction or source of data, you need to have somewhere where you store your data, a persistent where you can store your data. So that's what you have in industry dating. So that's the first point that you need to have, that you need to have data warehouse, whether provided by I prefer the one provided by Computer Science Zimbabwe, which is a software data platform um, that is readily available to the market. And yeah, we ingest data from every source into the platform. So data extraction method, you can extract it from like you said about web crawling, and that already open source tools that are available for in terms of achieving these tasks with Apache Nutch, there's Scrapy with Common Core, then database ingestion method. Maybe you're taking your data from the platform that the database platform that we have, which is Oracle, MySQL, Postgres, Mongo, Cassandra, etc. We have Debezium that is being used to actually capture the changes that from the database to your data platform. Then we have file document injection tools like Apache NiFi, Also, Spark API injection, Kafka. Um, these are these are tools which are very important in in terms of data extracting data to your data lake or data warehouse platform, and this ensures that um, you've data um, for both descriptive and training your AI models. So data is you get raw data from the sources that we've discussed earlier on, then you put it in a data lake or data wave for the model training. Now, most we are going to deep dive into one of the most important things about AI model training, which is cleaning of data. In industry, this is where heavy of the work is being concentrated on, because the the quality of data is the one that ensures that we have a better model. So that's where most of the work is most like 80% of the work is concentrated on cleaning of data. So it's a very important task in the industry. So I don't know if you know about the company Scale AI. Um, it is a company that deals basically on the cleaning of data. So one of the most important things that I need you to see is how important is cleaning of data. We actually use machine learning models to actually clean data. So we use other models to actually clean the data. This is an example of a situation where I need you to see that it's actually important how data cleaning is actually important in terms of in terms of training AI models. So one of the important things that is is being used by in industry to train data in large quantity, large data sets is Apache Spark. The reason because it is an in-memory processing. When we say in-memory processing, we, it relies heavily. The processing is done in memory, which is in RAM, which is very faster, and it allows you can set up Spark in a distributed manner, which ensures that uh, a billion of petabytes of that uh, uh, they can be cleaned in no time, and yeah, it is optimizing. It is industry tested. Many companies use Spark. Uh, Most of the paying companies use Spark in terms of doing data. So um, some of the you may ask why uh, some of the things that I've done during training data is deduplication. May I ask why uh, deduplication is being done? Um, deduplication, we do it because um, we're trying to reduce bias. So when you're training a model and there's data that keeps seeing the training said that it keeps seeing it it, it becomes biased towards that data. For example, it keeps seeing webs a lot. It becomes biased towards webs. So that's why um, data cleaning, one of the techniques is deduplication, trying to remove um, repetitive data, and content and filtering, remove names, phone number, IDs, and so forth. So the tools that for each is being you can see we have custom widgets, um, sparse spaCy, and deduplication spikes with Spark, MinHash, MinHash, just then with Heuristic rule filtering, rules on token lengths, language coherence, code quality, Apache Spark is heavily used. Model-based quality scores, score, high quality jobs, fastText, any of the schema normalization. Yeah, so this is the most of the tasks that that you need to ensure that the data is actually cleaned before you train your AI models. 80% of the work is done on cleaning. Once you see that your data is actually cleaned, then you can go ahead and train your models. As I indicated earlier on, um, quality of data ensures that we have a better model. So we ensure that the data is of high quality rather than quantity. So that's for data cleaning, and we're going to move on to the compute, which is very important. The right hardware for the right workload. So in terms of data cleaning and ETL process, data extraction, data cleaning, we the industry really rely heavily on best CPUs. If you're doing data cleaning and extraction and you use GPUs, doesn't make sense. You actually um, you're actually wasting the GPUs. So data cleaning and data extraction is you use CPUs, and for model training, that's why we use GPUs and inference. This is this heavily need GPUs. So the rule of thumb is CPU clusters clean data and data extraction. GPU clusters train and save the model. It, don't use GPUs for ETL. It's wasteful and it's expensive. So if you want to look more on the specific of hardware that in terms of GPU that is being used in industry. We have A100, H100. We also have the one that are not being specified, the NVIDIA super computer with PGX. With other 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 machines which cost nearly like these are H100 and A100. These are most expensive, expensive GPUs. We have the least expensive GPUs that range from 10,000 to 30,000. Um, I think there's is it RTX? I have to check again whether it is RTX, but we have uh, machines that the GPUs machine that can range from 10,000 to 30,000, which also for for small companies and those that are not like XAI, which have a huge class of GPUs which consist of H100, and that's it for compute. Before we talk anything about training, uh, one of the most important things is we have the infrastructure to actually train the model, and also for inferencing both the CPU and GPUs. CPU for data extraction and cleaning, GPU for model training inference. So you need to ensure that you have the right hardware for the workload. You, if you are training a model with low parameters, low parameters, which is not that complex, you don't need H100, H100 and A100s, A100. Just need maybe to purchase a a machine which low cost GPUs. So we are going to move on to next, which is AI saving and hosting. This is the most important part, which is very close by many AI companies, the ChatGPT, Anthropic, which provide cloud, and in this DeepSeek, and all the AI companies that that provide that was LLM at scale. So this is the most closed part that you cannot find this on textbook. This is the closed technology stack that whether ChatGPT or Claude, they know this by themselves. And this is the most difficult part. It's actually important as training. This in terms of AI, AI saving and hosting. I think most of you have used DeepSeek, and you can actually see sometimes when you provide your prompt, it might take time to respond to the prompt. This is because of AI saving, which is very, very, very important. This is very important. The ways of I'm just going to give you how this is ways how AI saving is done, but this is not the actual uh, in detail what is being done, what is being done by ChatGPT or cloud. But these are the techniques that they use. But maybe you can think like we have all the ways in which you can how to optimize inferencing and AI saving. But you have this, yes, you can have this, but how to do it, the way to do it, that is difficult, and it requires great engineers, and that what is closed. So back from the example that I was discussing or describing, you've seen DeepSeek. It was taking time for some time to give speed response when you provided a prompt. This is because of AI saving. This is because of AI saving. Uh, this is because of AI saving. It requires a lot of uh, technical know-how on serving your module to your customers. You know, roughly the amount that you you spend on training is actually equally the same amount that you serve, that is you're going to incur in saving um, in saving in AI saving and hosting. So yeah, so one of the I'm just going to run through the ways that you can do in terms of AI or saving and hosting. Yeah, first is KV cache. So this is where you reuse attention key value pairs across tokens. This avoids recomputing previous context in each decoding step, critical for long sequences. Then we have quantization, quantization is, the is actually trying to compress words from whether it is FP32 to int4 or FP32, FP16 or int8. So this actually reduces VRAM footprint, enables larger modules on smaller hardware. On smaller hardware. By using this technique, you can actually run your AI model on a very on a small number of GPUs, which is important. Or if you want to force things, you can actually run your LLM model on CPU, but it is very your system will be very slow if you are running on CPU. Be very slow, but it can be done, but there's greatly performance issues. Then we have model parallelism, where you can pipeline parallelism, split the model layers across GPUs required when model exceeds single GPU VRAM. This is what actually most big tech companies do, the model parallelism. And in model parallelism, you can actually split the model. But this one is very difficult. You split the model into chunks, then you place it on a distributed computing environment. Then when a this is very difficult. I take it. It, it can work on a conceptual basis, but it's very difficult to implement in real world. Then with continuous batching, whereby we're trying to process multiple uh, multiple user requests simultaneously in one forward pass, dramatically increasing GPU throughput versus sequential saving. Then we have speculative decoding, use a small draft model to propose tokens, large model um, uh, uh, very, verifies in parallel, achieving 2 times or 3 times speed up with no quality loss. Then we have inference frameworks. These are ones are actually very important with open source V, LLM, with TensorRT, LLM, TGI. These are important, especially for your own created models. But one thing that I want you to take note is, in industry, it is rather better to use already existing open source AI models than just fine tune them. It actually it saves cost and and time to market. The issue of training your models from scratch is in industry is not highly recommended. It's not a practice that in industry that we do in terms of you cannot. It's actually expensive to train a model from scratch. It's better to just take an open source model, then you fine tune it, then you deploy it. That is very, which is which is which is sound in business perspective. So just to summarize, things that are very important takeaways when building AI. Your data set, your data set is your moat. So your data is very important. From your database, code send Excel files. Yeah, that one is very important. You must the data that data is very important. Then ETL and cleaning is 80% of the work. 80% of the work is it comes from cleaning of your data and the extraction of your data. So as I highlighted earlier on, quality of your data is more important than the architecture, the model architecture itself, or and the complexity of the architecture. Um, there are also some studies that have shown that most of the complex model model architectures, they're not they're actually being underutilized. So it's better to have quality data than a minimum complex model architecture, which actually make you, in business perspective, yeah, you save cost. Then use Spark, really use Spark, and also you need to have your data infrastructure. Uh, I prefer to use so-called data platform, which is provided by Computer Science Zimbabwe. Then use Spark and CPU cluster for cleaning. A distributed CPU system handle duplication, filtering, normalization more cost effective than GPUs. So, as I said earlier on, heavily use CPUs for data cleaning and instruction, and GPUs for data model training and inference. Don't use GPUs for data cleaning and extraction. It's rather better to use it use CPUs for data extraction, cleaning, then GPUs for training and inferencing. Then we have you need to understand to be aware of scaling laws, guide optimum compute location before committing to preemptive training. You know, you can actually able to calculate the amount of um, the amount of money that you require for training your AI models, the time that you're going to estimate of the time that you is going to it is going to take for training AI models, which is very important, and saving. One of the last point that I was discussing is saving is hard as training. So this is the most the very difficult part in the saving part, the saving of, AI models. Uh, e- so one of the techniques that are available, KV cache, quantization, and continuous batching, and non-negotiable for production LLMs, LLM deployment. Whether you're deploying an AI model that you train from scratch, or open source model that you fine tuned. These are the techniques that you use, but I didn't dive deep on actual ways that you can actually optimize these. Um, but these are the techniques that you can actually use in terms of AI saving while maintaining costs and for better performance. Because at the end of the time, uh, in industry, you need to provide the product at minimum cost. Minimum cost, if that can be done. So thank you very much for uh, tuning to this uh, discussion about AI in industry. So we're going to on our next session, uh, we're going to dig deep dive um, on ways also of optimizing module. Today we're focusing on the data aspect and in the infrastructure part, which is the core of building AI models. So thank you.